Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube. Good morning. Today, I am discussing about two-stroke cycle engine. Two-stroke, a British engineer introduced a cycle which could be completed in two-stroke piston rather than four-stroke, as in the case of the four-stroke cycle engine. The engines using this cycle were called two-stroke cycle engine. In this engine, suction and exhaust strokes are eliminated. Here, instead of valves, ports are used. The exhaust gases are driven out from the engine cylinder by the fresh charge of fuel entering the cylinder nearly at the end of the working stroke. Two-stroke petrol engine used in scooter, motorcycle, etc. The cylinder L is connected to a closed tank chamber. During the upward stroke of the piston, the gases in L are compressed, and at the same time fresh air in the fuel mixer enters the crank chamber through the valve. When the piston moves downward, V closes and the mixer in the crank chamber is compressed. Ignition takes place at the end of the stroke. The piston then travel downward due to expansion of the gases. And near the end of the stroke, the piston uncover exhaust port. Two-stroke engine. That is the two-stroke engine, the diagram of the two-stroke engine, spark plug, and this one, that is the diagram of the two-stroke engine. Now, intake, expansion and release, as well as compression. This is the intake for a compression ignition engine. The compression ignition engines are operated unthrottled with engine speed and power controlled by the amount of fuel injected during each cycle. This allows for high volumetric efficiency at all speed with the intake system designed for very little flow restriction in the incoming air. Further raising the volumetric efficiency is the fact that no fuel is added until late in compression stroke. After air intake is fully completed, in addition, many CI engines are turbocharged, which enhance air intake even more. The addition of fuel made late in the compression stroke, starting somewhere around 20 degrees before TDC, injector mounted in the cylinder head and inject directly into the combustion chamber, where self-ignition occurs due to the high temperature of the air caused by compression in heating. It is important that fuel with the correct Ceten number be used in an engine so that self-ignition initiates the start of combustion at the proper cycle position. For CI engine, the injection pressure must be much higher than the required for SI engine. The cylinder pressure into which the fuel is the first injected is very high near the end of the compression stroke due to high compression ratio of CI engine. By the time the final fuel is injected, peak pressure during combustion is being experienced. Pressure must be high enough so that fuel spray will penetrate across the entire combustion chamber. Injection pressure 200 bar to 2000 bar are common with average fuel droplet size generally decreasing with increasing pressure. Orifice hole size of injector is typically in the range of 0.2 to 1 millimeter diameter. The mass flow rate of fuel through an injector during injection is given by the relation m dot f. So that is equal to CD an root over 2 rho f delta p. The total mass of fuel injected into one cylinder during one cycle is given by mf CD an root over 2 rho f delta p. Discharge of coefficient injector, flow area of the nozzle orifice, rho f, density of fuel, delta p, pressure of differential across the injector, n engine speed. So comparison of 4-stroke cycle, actually large engine must have very high injection pressure and high spray velocity for optimum fuel viscosity and spray penetration. It is important to have fuel at the correct temperature. Comparison of 4-stroke and 2-stroke cycle engine. First one is completion of the cycle. 4-stroke cycle engine, the cycle is completed in 4-stroke of the piston or in 2 revolution of the crankshaft. Thus, 1 power stroke is obtained in every 2 revolution of the crankshaft. The cycle is completed in 2 strokes of the piston or in 1 revolution of the crankshaft. Thus, 1 power stroke is obtained in each revolution of the crankshaft. Flywheel required heavier or lighter. Because of the above turning movement is not so uniform and hence heavier flywheel is needed. More uniform turning movement and hence lighter flywheel is needed. Power produced for same size of engine. Again, because of 1 power stroke for 2 revolution, power produced for same size engine is small, or for the same power the engine is heavy and bulky. Because of 1 power stroke for 1 revolution, power produced for small size engine is more, theoretically twice, actually about 1.3 times, or for the same power the engine is light and compact. Cooling and lubrication required. Because of 1 power stroke in 2 revolution, lesser cooling and lubrication requirement. Lesser rates of wear and tear. Because of 1 power stroke in 1 revolution, greater cooling, lubrication requirement, greater rate, wear and tear. Valve mechanism. The 4-stroke engine contains valve and valve mechanism. 2-stroke engine have no valves but only ports. Some 2-strokes engine are fitted with conventional exhaust valve. Because of the heavy weight and complication of valve mechanism, higher is the initial cost. Because of light weight and simplicity due to absence of valve mechanism, cheaper in initial cost. Thermal and part load efficiently. Thermal efficiency, higher part load efficiency better than 2-stroke cycle efficiency engine. Thermal efficiency, lower part load efficiency lesser than 4-stroke cycle engine. Used where efficiency is important in cars, buses, trucks, tractor, industrial engine, aeroplane, power generator. In 2-stroke petrol engine, some fuel is exhausted during scavenging. Used where low cost and compactness. Aspect, thermodynamic cycle. What is the difference between SI engine and CI engine? What is the difference between SI and CI engine? Thermodynamic cycle, Otto cycle, another one is the diesel cycle. SI engine, CI, diesel cycle for slow speed engine, dual C cycle for high speed engine. CI, SI auto, fuel used, that is the petrol and diesel, air fuel ratio 10:1 to 20:1, CI engine 18:1 to 100:1. Compression ratio up to 11, up to 12 to 24. Combustion, spark ignition, CI engine, CI engine হচ্ছে compression ignition. Fuel supply by carburetor, by injection expensive method. Operating pressure 7 bar to 15 bar and 45 bar to 60 bar, 30 bar to 50 bar and 60 bar to 120 bar. Operating speed, high speed 2000 to 6000 rpm, low speed 400 rpm, medium speed 400 to 1200 rpm. Control of power, quantity governing by throttle, quality governing by rack. Calorific value 44 megajoule per kg, 42 megajoule per kg. Cost of running, high and low. Maintenance cost, minor maintenance required, major overall requirement but less frequently. Supercharging, limited by detonation, used only in aircraft engine, less suitable, limited by blower power and mechanical thermal stresses, widely used. Two-stroke operation, fuel loss in scavenging, but small two-stroke engines are used in mopeds, scooter and motorcycle due to their simplicity and low cost. No fuel loss in scavenging, more suitable. High power, that is the no, another one is the yes. Distribution of fuel air fuel ratio is not optimum in multi-cylinder engine. Excellent distribution of fuel in multi-cylinder engine. Starting easy, low cranking effort, difficult, high cranking effort. Exhaust gas temperature high due to low thermal efficiency, low due to high thermal efficiency. Weight per unit power, initial cost low, initial capital cost low. Another one is the high due to heavy weight and sturdy construction. Noise and vibration, one is less, another one is the more idle noise problem. User, mopeds, scooter and motorcycle, simple engine, passenger, buses, trucks, this one. Petrol engine and diesel engine, air, petrol mixture is sucked in the engine cylinder during suction stroke. Only air is sucked during suction stroke. Spark plug is used, employs an injector. Power is produced by spark ignition engine, spark ignition. Power is produced by compression ignition. Thermal efficiency up to 25%, thermal efficiency up to 40%. Occupies less space, occupies more space. More running cost, less running cost. Light in weight, heavy in weight. Fuel, petrol is costlier, diesel is cheaper. Pre-ignition possible, pre-ignition not possible. Works on auto cycle, works on diesel cycle. Less dependable, more dependable. Another one, how to tell two-stroke engine from a four-stroke engine cycle. Two-stroke cycle engine, how to tell a two-stroke cycle engine from a four-stroke cycle engine. Actually, four-stroke distinguishing features, oil sump and oil filter plug. It has a oil sump and oil filter plug. Four-stroke, two-stroke, it does not have oil sump and oil filter plug. It requires oil, drain and refill periodically, just an automobile do. In this type of engine, the oil is added to the gasoline so that a mixture of gasoline and oil passes through the crankshaft. Location of muffler. It is installed at the head end of the cylinder at the exhaust valve location. It is installed towards the middle of the cylinder at the exhaust port location. Nameplate. If the nameplate mention the type of oil and the crankcase capacity or similar data, it is 4-stroke cycle engine. If the nameplate tells to mix oil with the gasoline, it is a 2-stroke cycle engine. Okay, so these are the differences between 2-stroke cycle and 4-stroke cycle. Now highlights any type of engine and machine which derive the heat energy from a combustion of fuel or any other source and convert this energy into mechanical work is termed as a heat engine. The function of a carburetor is to atomize and meter the liquid fuel and mix it with air as it enters the injection system of the engine, maintaining under all conditions of operation fuel air proportion and approximate to this condition. The two basic ignition system is current user battery coil ignition system, magneto ignition system. Following are the methods of governing IC engine. First one is the hit and miss method, quality governing. Another now the octane number is the percentage of octane in the mixer, isooctane high rating and normal heptane low rating by volume, which knocks under the same condition as the fuel. Delay period of ignition lag is the time immediately following injection of fuel, during which the ignition process is being initiated and the pressure does not rise beyond the value it would have due to compression of air. Higher the C10 rating of the fuel, lesser is the proportionality. The another one is the higher the C10. The purpose of supercharging is to raise the volumetric efficiency. The above that the value that which can be obtained by normal aspiration. Performance of IC engine. Indicated diagram, indicated power, the formula. Another one is the brake power, mechanical efficiency, brake power by EP, BP, brake power by indicated power, thermal efficiency, indicated power by m dot f dot c, thermal efficiency, that is the brake power divided by m dot f into c. So another one is the relative efficiency, thermal efficiency, air standard. Measurement of air consumption by the box method. Volume of air passing through the orifice, that is the Vm is equal to the 840 ACD HW by rho 0. Mass of air passing through the orifice m dot a 0.666 CD into dn d to the power n d square root over of HW rho a kilojoule per minute. A is the area of the orifice, D diameter of the orifice, HW head of water causing the flow, rho a density of air kilogram per meter cube under atmospheric condition. So this is the discussion. Student, you should apply the formula in your numerical problem. Okay. Okay, thank you. Last, if you like my video, you have to subscribe. Okay, thank you.